Hi, everyone. Can everyone hear me? Okay, thank you so much for coming. And this talk is only about my trust issues, right? No, kidding. This is me. My name is Bijoya Chatterjee. I am a senior software QA manager at Sony PlayStation. How many of us are console users? PS4, PS3? Okay. For the rest of you, you're missing out on the greatest thing in life. So I have been involved in UI automation for more than 14 years now, almost coming up to 15 years now. I'm very, very passionate about automation, very passionate about making sure that we are doing it right, and specifically very passionate about stability in automation to make sure that we are getting the return on investment that we are putting in. Just a quick introduction for those of you who are not familiar with the PlayStation brand. We are, like I said, the greatest gaming console on earth. We have millions of users across the world, and just to give you a perspective, if the PS4 goes down for an hour, we lose tens of millions of dollars per hour. So that's the kind of quality we have to maintain to make sure that we are not sending out defects or bugs into production. So all of us here, pretty much, I think, are already converted. We know that manual testing is bad. We know that automation is good, right? We are all proponents of automation. We heard Charles say in the morning today that manual testing is dead, and I think that most of us in this room, all of us, believe in that. What I want to talk about is that, yes, automation is the way to go, but we need to make sure that we understand that it is automation, it's not automagic. Things don't happen magically. If developers write code, it needs to be tested and it needs to be maintained. Nobody expects magic out of development code. We should not expect magic out of automation code also. It's just software code. We need to make sure that we keep that in mind. With that, I want to bring you to my personal grief with automation. It's great. It solves all our purposes. It makes sure that we can get to the release windows. We can release high-density products every week, every day, on demand. But as soon as we start adding automation tests to our suite, as soon as our regression suite bulks up, as soon as we have 3,000, 4,000, like us, 10,000 automation test cases, end-to-end functional automation test cases, stability takes a nosedive. And this has been my pet peeve for the entirety of my career. This has been the problem with automation that I have been trying to solve for most of my career. That we put in so much effort in automation, but stability of UI automation, stability of functional automation, takes a nosedive as soon as you bulk up the suite. This is what our analysis looked like for our regression suite. Like I mentioned, our regression suite looked to have about 10,000 test cases. It is kicked off every night. It takes close to 20 hours to run on a very high density farm. And when we looked at the analysis of failed builds, we realized that we were getting 3% of the failures because of defects, because of product defects. The rest of the 97% was either because the script was badly written, was because the network went down, was because some other team somewhere kicked off a performance run and it clogged up the network and pages wouldn't load. That's what was happening with the rest of the 97%. So the return on investment of all those 10,000 test cases that we had written, the entirety of my team was 3%. That was what we were seeing. The result? Ignore the results, right? That's what happens. Time and time over, I would get requests from the dev team, from the release team, to say, why don't you have your team quickly do a round of manual and ad hoc and let the release go? Because nobody trusts the regression results, right? It always fails. Who's going to take the next 20 hours to analyze the results, to identify that small 3% that is actually identifying product defects? Who's going to wait for that? We need a release every day. We need a release on demand, right? So you ignore regression results. That's what keeps on happening. That's the reality of having a high bulk regression suite. What we did was identify the primary problems of end-to-end automation, of UI automation, and we realized that there were three main problems that we needed to contend with. We needed to contend with stabilization. We needed stable test cases. There was no going around that problem. There is no going around the problem that if you have invested, if you have put in time to write automation, you need to put in effort to stabilize your suite. We also realized that end-to-end automation inherently is a high maintenance job. You need to put in effort to make sure that your end-to-end automation suite is maintained. It's not getting rusty. And we need to put in time for analysis. Remember the 20 hours that it took for our regression suite to run? It took another 24 hours to analyze it. And that's manpower down the drain, right? Those are the three problems that we were contending with. Then we looked at why the failures were happening. The failures were happening randomly, all over the place. We couldn't predict. If we could predict, we could solve it, but we really couldn't predict. So we took a huge number of regression runs and we analyzed and put them into broader buckets. And these are the three buckets that we came up with. There was the inherent badly written script. I am guilty of it. I have written sleep statements in my test script and merged them in. I'm pretty sure most of us in this room have done it at some point in their career. That's just one example. There are multiple examples of badly written scripts. There's always the environment issue. Something went wrong in the environment that you were depending on for your test. You needed an account. That account didn't exist on your machine. Something went wrong with the environment and your tests depended on that. And network issue. Remember that performance suite that was kicked off and clogged up the network? None of the pages loaded, so the script timed out. We went through hundreds and hundreds of test cases, and we realized that these were the three primary things that we could identify and put in the buckets: the badly written script, the environment issue, and the network issue. Our reaction: make a small change, merge it in, check to see if it works for some time, it starts failing again, take another knee-jerk reaction, make another small change, merge it in, go on and go on and go on. Rinse and repeat, it's a shampoo cycle, right? You go on doing this and you start looking like that. That's where TSVS comes in. We named it TSVS because we think it's a tongue twister, and I'm going to ask you guys to repeat that after me. No, we named it TSVS because it's a test stability validation service. What it is a service that validates the stability of your test suite. It's a self-contained plugin service. It plugs into your CI. So whatever the service needs is contained within that service. It'll plug in within your CI, and it'll run automatically every time you are trying to merge a test or you're trying to run a regression suite. It increases automation reliability. That's the reason we created it, right? It increases automation reliability so that you can ultimately have confidence on your automation runs. You can ultimately say that when your automation runs, if it fails, it's identifying a product defect. And it also let us work towards that golden 100% test automation. We stopped wasting manpower towards analysis of test runs. We stopped wasting manpower at trying to take a reactive approach towards maintaining test scripts, to make that small change and to merge it again. So we could work towards that 100% automation. After TSVS, all code that comes in with 100% automation. All the test cases are automated before the development code is merged in. Now let's look at TSVS and what it is. I'm going to gleam over this slide quickly because I've mostly talked about what it is. Like I said, it's a standalone CI plugin. It monitors the health of the test script, not just before the test script is integrated, but it continues to monitor the health of the test script even after it is integrated. You may write a great test script. You may validate that it is stable. You integrate it. I can bet after 3 months, it'll start getting flaky again. So you need a constant monitoring program to make sure that that stable test script that you integrated and merged in and is running as part of the nightly regression runs continues to stay stable. And if it doesn't stay stable, then the service will take corrective action to make sure that it gets back to a healthy state. That's what TSVS does. Like I said, there are two pillars to TSVS, testing and maintenance. Just like any other software, test automation is just like any other software. It needs to be tested and it needs to be maintained. And those are the two primary pillars on which TSVS is formed. Looking at test first, we will test the test scripts before they are merged in. When the tester writes the test script, that is when those tests need to be tested, not after they have been integrated into the regression suite and not during the regression cycle when they will fail. That's not when you test it. You test it before it gets integrated into the regression suite. How do you do it? You do it by these 5 steps. I'm going to take you through these 5 steps. The first one is static code analysis. It seems very intuitive for development code. We've seen static code analysis happen for dev code all the time. Just to give you a perspective for those of us who aren't very clear about what static code analysis is, it's basically analyzing the code without executing it. It's going through the code and checking to see if it finds rules that are already coded within the analyzer to flag errors or warnings. So remember that sleep statement that you were trying to merge in, the analyzer will catch that. If you have that rule developed within the analyzer, it'll catch that and flag it as an error. We take analyzers that are available in the market, but we do customize the rules very, very strictly. So we have very strict rules to go through the test code to make sure that anything that is questionable is flagged as an error. And then there are ample warnings to the tester to make sure that he is looking at the code. The next one is runtime. With this step, what we are trying to do is find that sweet spot of granularization of your test script. I have personally seen test scripts that go through 15 screens, have 20 plus assertions. It's running for 20 minutes. It's bound to fail. However, you also should not write test scripts that are granular and check one minuscule on the screen. You should find, depending on your context, find that sweet spot of how much should be tested within a test case. In our environment, the default is 2. But this is configurable, so you can change the default depending on your environment. And runtime checks to see how long the test script runs for and makes an assessment of whether it has hit that sweet spot or not. Failure rate is pretty intuitive. We run the test case 5 times. Again, configurable. You can run it for 10 times. The default is 5 to make sure that there are no failures within that test run. If it starts failing even while it is being tested, there are chances it's going to fail when you integrate it into the regression suite. So you run it multiple times within the environment and make sure that there are no failures. Parallel runs, this takes care of the problem of test cases written for only Chrome or only IE10, right? I've seen multiple cases where the tester will test it very heavily in their local environment and then check it in and it starts failing on everything other than just one browser or one Android version. This will run the test case across all platforms, across all versions that the application supports, and make sure that there are no environmental dependencies that are hard-coded within the test case. Sequential run. So you've written a great test case. Your test case tests exactly what it's supposed to do. It does its job, but the setup and the teardown class basically messes up the environment. So when it's exiting, the test case basically deletes critical things from the environment and exits. The test case will pass. Even the 5 times that you run it, it'll pass. But everything after it is going to fail when you integrate it into the regression suite. So what the sequential execution does is randomly pick a few other test cases from the regression suite, insert this test case, and run that set to make sure that not only does this test case pass, but the test cases that happen before it and after it pass also. The important thing to remember is that all of these 5 steps need to pass for us to be able to merge in the test case. This is integrated as a service into the CI module. So the merge button is not enabled up until all of these 5 stages have run and have passed. If there is any failure within these 5 stages, the merge stays disabled, and the tester needs to take care of it, right? So all of this needs to run, all of this needs to pass, and you have a pretty good guarantee that you've written a good test case that is stable and will run. You have gained granularity. You have gained a well-written test case. You have gotten over the usual bumps of, well, it was written only for IE. It passed in my local environment. Well, you're forcing the test case to run in your CI environment. So even if it passes on your local machine and it fails somewhere else, that's a failure. So you gain all of this through using those 5 steps before you merge in a test case. Remember those 3 primary things that we had identified when we were looking at all the failures that we were seeing in our regression suite: the badly written script, the environment issue, and the network issue. By testing the test case before it gets merged in, and by making sure that we have looked at all angles of testing, we take care of the badly written script. We also take care of some parts of environmental and network issue, but the primary hit over here is the badly written script. This will get caught by that module. So you're good, right? You wrote a great test case, you merged it in, you're done. I remember personally the first time I ran through that module, I could check in. I didn't look like that, but I looked pretty ecstatic. I was ready to do a victory dance. I was done. I could go home. I thought that all was well, and all was going to remain well. Reality looked a little different. We saw many more test cases passing in the regression suite, but we did not see the green bells. Not all test cases were passing, and we could not guarantee the results. We still could not. The builds were looking much better. The analysis time had come down by quite a bit, but it still wasn't at that point where we wanted it to be. It still wasn't perfect. Maintenance. That's the next pillar, right? That's what we need to take care of after the test script is merged in. What does the maintenance part of it do? What does that service do? It runs as part of the nightly, so the tester doesn't need to do anything. It runs automatically as part of the nightly regression run. It works on identifying the tests that are failing by the pattern of retries and why it is failing. It identifies the reason for the failure through that pattern, analyzes the failures to identify whether it's an environment issue. So we have, at that point, an answer of whether the test case is failing because there is something that's wrong with the environment that really has nothing to do with either the product or the test case. It also handles flaky test cases. The word flaky is a bad word for all testers. And it helps identify flaky test cases, but it also helps take corrective actions against flaky test cases, and I'll get into the details of that. And it also generates a master report. We can do great fancy things, but we also need to make sure that we are aggregating and summarizing and visualizing the results for easy consumption. We can do all of these things, but if the tester or the person looking at the report doesn't understand it, it really doesn't make sense. These are the steps of test maintenance that we go through as part of the nightly regression run. The first part is test execution. What we realized is that for a suite that is as huge as 10,000, we need to break it up into smaller chunks. And we need to take corrective action between the chunks, like reboot the machine, like check and audit the environment to make sure that all the accounts that we need in that environment are still present. So we break it up. The regression suite, it doesn't create multiple jobs, but then the single job acts into breaking up smaller chunks and takes corrective action between chunks. The next step is failure. This is an important part, so I'm going to go into a little more detail of what we do with the log analysis and the failure. When there is a failure, when a test case does fail, we run the log analyzer. What we have in the log analyzer is basically a library of known error codes. We know the error codes that would come back, for example, if there is a microservice that is not working, or there's an API call that is not returning the correct value. We have all those error codes. When there is a failure, we run the log analyzer, or the module runs the log analyzer to identify whether any of the known error codes are present or not. If they are present, then that test case is deemed as an error versus a failure. The error is an environment issue that we really don't have control over. That microservice was down. It really doesn't point to a product defect or a test case defect. So that is where the segregation happens between an error versus a failure. A failure could still mean a product defect. If we don't find that error code within the logs, it could still mean that we have a regression or an integration bug that got introduced. After we've run the log analyzer, we run the retry loop. What the retry loop does is every time there is an error test case, since it's an environment issue, it'll run it against mock services. So that we can be 100% sure that it is actually an environment issue. If there is an API or a server that is down, a backend server that is down, if we run it against mock services, it'll pass, and we know for sure that it's an environment issue. We also update test summaries after the retries. So if it continues to fail and we haven't identified as an error, we will mark it as a failure, but we will keep updating the test summary with all the retries that has happened on the test case. And we will retry the test scripts that are only failed. After the mock services, if it's still deemed as an error, we will keep it as an error and we won't retry it because we know why it's failing. What this helps is create also a heat map that we generate out of this. The heat map generally goes between red and green, various shades of red, orange, yellow, and green, and that identifies areas of the application as well as test functionalities that typically have failures or typically have flaky tests. So if you see a feature that always has test cases associated with it that are always coming out as red, that needs a little more attention. The heat map will guide you towards that. You remember the retry, right? We are retrying the test case that is deemed as a failure multiple times. This generates what we call the variability or the flaky threshold, the variability threshold. What it means is that if the test case passes a few times and fails a few times, it should be marked as flaky. And you should have a threshold to say, these many times having a difference is okay, but then beyond that, it's a flaky test case. You can set the variability threshold to be 0. You can be very, very strict in your environment to say, anytime a test case moves between a pass and a fail, it should be deemed as flaky. But what flaky and variability threshold does for us is that it also triggers another service that will auto-disable the test case and log a defect against it. Log a defect against it that is set according to the priority of the test case. So if it's a P1 test case, it will log a severity 1 defect and assign it to the author of the test case. So the next morning when the team is doing a bug triage, these critical defects will percolate up. It's a forcing function for the testers to go, make that change, rectify the test case, run it through those 5 steps before it gets merged in, and then merge it back into the regression suite. I did talk about reporting. It is that action that summarizes all of this information, visualizes it in a format that is easy to understand. All the disabled test cases, all the test cases that were deemed as flaky, the heat map, the error test cases that will let us identify services or backend services or APIs that are not working correctly, and visualize that into a dashboard for consumption by the team. All of this runs as a service within the regression run. So as soon as you kick off the nightly regression run, all of these things will run, and then it will generate the report at the end of the day, which will show you how many test cases passed, how many test cases failed, and will analyze the failures for you. Coming back to those 3 problems that we had, the 3 problem children that we had, the badly written script, the environment issue, and the network issue. The badly written script was more or less taken care of before we merged in the test case. After running the maintenance part of it during regression, we take care of the environment issue and the network issue. We have identified where the environment issues are happening and where the network issues are happening, and we've rectified and identified error test cases versus failed test cases, and we've disabled them and logged bugs. Summarization of TSVS, it's not a tongue twister. It is making sure that we are testing and maintaining test code before it is merged in and maintaining it after it is merged in. It needs to be looked after exactly the same way that dev code is looked after. You wouldn't release dev code to production without testing it. Why would you merge in test cases into your nightly regression suite without testing them? You wouldn't write dev code and keep it there without maintenance. Why would you do that with test code? So you need to test it and you need to maintain it. You need to treat test automation scripts the same way you treat any other software. The regression analysis that I talked about, the 3% return on investment that we were getting out of the 10,000 test cases that we had, for my entire team working day and night to create that huge regression suite. After we implemented TSVS and after we fine-tuned it, this is the difference we saw. 83% of the problems that were reported through the regression suite were actually identifying product defects. So not only had we increased the stability of the regression suite, we had also been able to get to product defects faster and easier through our regression run. Our regression test cases were actually doing the work it was supposed to do, identify regression and integration defects. That's the difference that we had. The stability of the regression suite increased by 85%. So 85% of the time we saw green builds. Out of the 15% times that we saw a failing build, the test cases that failed, 83% of those were failing because there was a regression introduced, or there was an integration defect introduced. We were creating more automation in less time, obviously, because we were not wasting manpower in analysis and knee-jerk maintenance. We had reduced the release window from 3 months to 1 week. We can now release every week without failure. Obviously, there is defect identification. The cost of defect identification takes a nosedive if you're actually finding it through automation and through your regression runs. And you'd created maintainable code in the automation suite. We are working on quite a few improvements for TSVS. While it is fantastic for us right now, there are places where we can improve it. For example, sequential testing, the place where we identify random test cases, and your test case gets integrated within that before you merge it in. That is a random set. We are trying to create intelligent logic where we can identify test cases that actually will have an effect on the test case that you're trying to merge, and then run it as a set of those test cases. We are also trying to do reverse defect integration. So when you do identify a flaky test and the service disables the test and creates a defect automatically, the tester needs to make that change to the script and manually re-enable the test case. What we are trying to do is make sure that every time those defects are getting closed, the test case associated with it will automatically get enabled. We are also eliminating chunking. Instead of taking corrective actions within chunks, we are trying to get to a point where we can take corrective action when we see a problem. We are trying to integrate that logic to identify a problem correctly, to identify what went wrong and why it went wrong, and then take a corrective action on the environment or the machine, and eliminate chunking. This will eliminate a lot of time that gets added by chunking. And of course, zero variability threshold. So flaky, like I said, is a bad word. And anytime there is any flakiness in a test case, anytime there is any variation in the passing and the failing between retries, that should be marked as flaky. And the variability threshold should be 0. It's not auto magic, it's automation. You have to remember that. You can't expect magic out of a script just because you think it's going to work. You have to put in testing, and you have to put in a lot of effort to maintain your test code. That is all I had. I am open for questions.
Hi, the heat map seems quite rad. Have you been able to utilize the results from the heat map in interesting ways outside of strictly the purpose discussed here?
Right now, we are primarily using the heat map to identify flaky areas of the product itself. So, for example, if there are test cases that are specifically related to a feature in the product that keep failing, that basically identifies an area in the product that needs a little more attention. So it's not, the heat map is not just used for the test scripts, it is used for corrective action for the product itself.
We are currently looking at SonarQube for the static code analysis. Are there any other tools that you would recommend for that?
There are multiple, depends on what you need and how customizable the rules are and how customizable you need the tool to be. So you just have to do a research and check out what your requirements are. We needed the tool to be very customizable because we wanted it to be extremely strict.
Yeah, in your test phase, you had all of these checks before code could be merged in a pull request.
Yeah.
Do you have a separate like pull request pipeline for test code versus development code, or are they even different repositories?
No, they're not separate repos. We require sanity tests to pass for dev code to merge in. Think of this as the sanity testing for test code to merge in. In our environment, the pull request comes as a single pull request. Every dev code needs to come in with the complementary test, the automation code. So while the dev code is getting tested with the sanity test suite, the test code will get tested through the stages that I showed you.
Thank you.
Any other questions?
Hello.
Hi.
So you started with a rhetoric question whether everybody likes automation and believes that manual testing is dead. You know, I don't believe automation is good. And the reason is that I believe in return of investment of automation. And I have seen, you know, I'm doing automated testing more than 20 years.
Okay.
And before that, I was a developer many years. And I have seen that maybe 80% of automation products, they fail.
Okay.
Because of the only reason.
Yeah.
Only negative return of investment.
Right.
Even today, I have heard a story about Walmart. They invested a lot. So during 6 months, they automated all the test cases. And after 2 years, it failed. And they need to make measures. And maybe I'm not sure about your problem, but your project might fail as well. You mentioned some problems with automated test, and you haven't mentioned 2 of them. Maybe they are not related to you. About concurrency testing. If I start the same test on multiple environments, they might affect each other.
Okay.
And another problem about leftovers. Some tests might not remove the settings. So you log in as some user, you add some information, and then your test fails, and you didn't remove it, and next time it fails. So I'm advocating with my current management to automate as less as possible.
Okay.
Because I believe in many test cases, manual test is cheaper and just more effective.
I respect your thinking. However, the 2 specific examples that you took were actually problems for us also. And we do have stages in the testing phase. You mentioned concurrent testing. That is tested through the parallel execution in the testing phase, where we take the same test case and run it across all platforms and all versions that the application supports. And you mentioned the point where the test case messes up the environment. That is taken care of by the sequential runs, where we are making sure that we are actually integrating that test case within a smaller bundle of other test cases to make sure that the other test cases are passing after this test case exits. But you know, there could be more examples in your specific environment, and I respect your thinking. Any other questions?
You said there are 10,000 plus tests for your automation on the front end, right? So how are the numbers look like on your unit testing side, and what is the coverage you have on unit testing? And the second question I have is like, were there test data that played a role in flakiness of the tests?
Right. So first, let's talk about unit testing. We do have thresholds of unit testing, and one of the projects that we have is to make sure that we run those thresholds and not let dev code get merged in if the unit test numbers fall below a certain threshold. We haven't got there yet, but we have ambitions to get there. Regarding your second point about content setup, I think, product setup, that is taken care of in the environment issues that I talked about. Most of the environment issues that we were seeing were related to products that we were expecting to be there, but were not there, were either changed or deleted by someone else. And that is an environment issue that has nothing to do with application defect or test, or the test case. And those get caught in the environment issues.
Hey, okay, that's all we have time for. Thank you so much, Bijoya. This was wonderful.